We now take some time to discuss the concept of set and map and the classes in Java and C++ implementing them. A set is a collection containing no duplicates. So you can put things in a set and then you can check whether a particular thing exists or not. You can remove something from the set. And these operations are all performed efficiently. And there are two kinds of set. One is unordered, so there's no inherent order between we don't use any order between the elements. The other kind is an ordered set, where there is an ordering relation between the elements. And an ordered set will support efficient operation of finding the first. You can think of as the smallest element in the set, finding the biggest element in the set, or you can traverse the elements in the set in the order. So these operations are also efficiently supported. And then there are set operation of union, intersection, computing the difference of two sets, checking whether one is a subset of the other. So this operation in general will be at least linear in the size of the set, or at least if you are doing two set union together, at least the complexity will be proportional to the smaller one. So the Java set interface has these methods that are useful. So you can look at the Java the library document to see the details. But yeah, so here are the things that support subset, set union, set difference, and intersection. And in Java, we'll be using two classes for set. So hash set and tree set. Hash set is implemented using hashing, and it supports constant time operation, so it's pretty efficient. Tree set implement ordered set or sorted set. They implement the sorted set interface in Java, and it's implemented using a binary search tree. So the complexity are all log time. So these adding or removing, checking whether an element is in the set, those are all take log time. And C++ has unordered set and set, these two classes. So unordered set corresponds with hash set in Java. It's based on hash, and this operation takes constant time. Set is similar to tree set. It's an ordered set, and the operation takes a log time. And a map is a set of ordered pairs. So every pair is we call the first thing the key, the second thing a value. And in a given map, it's required that there are no duplicate keys. So you cannot have two elements that have the same key. So each key is mapped to one value. And different keys can be mapped to the same value. So there are several very important usages of map. One of them is to implement a multi-set. So if you are trying to maintain a collection of things where one thing can appear multiple times, so then you cannot use set, because the set, everything can only appear once. But you can use map. You can map each item to the number of times it appears. So then that's one usage. So that's also similar to the concept of histogram that we talked about earlier. And in fact, the map is in some sense similar to an array. So array can be viewed as a map from a set of integer indices to a set of values. So we use array when the items we care about can be easily mapped into a relatively small set of integers, say less than 10 to the 6. Then we can use an array to store this concept of mapping a key to a value, where the key is not stored implicitly. It's not stored explicitly, but rather it's using the indice as the implicit key. But when the key is large, when what we want to maintain information, even about integers, we want to maintain a histogram of integers. How many times each integer appears. If the integer is large, then we can use map to do that. So these are some of the methods in Java's map interface. We can get the value corresponding with the key. We can put a value corresponding with the key, remove a key, and so on. So we can go through all the entries in a map or all the keys in the map. And there is a helpful function introduced in Java 8 called merge. It kind of does something that's very natural, but without this function, it will take several lines of code. Essentially, we want to check whether if a key already exists, then we will sort of add this v value into the existing value, where this adding can be defined using a function, so it doesn't have to be an add. If the key does not exist, then we will use this. We will create this mapping of this key with this value, and then return this value. So this is very commonly used if you want to count how many times k appears, so that you will put the value 1 here, and if it doesn't appear, then that means it appears 0 times. You want to put a mapping of that item to 1. If it already appear, you want to add 1 to that value. So that's a very common usage. Java has 3 classes implementing the, maybe there are others, but these are the 3 most common ones implementing the map interface: hash table, hash map, and tree map. So we're not going to use hash table because it's essentially hash map with additional support for multi-threaded access, so which will have additional performance overhead. In competitive programming, we generally don't have multi-threaded program, so we don't need that synchronization support. So hash map has a amortized constant cost, and tree map has a log time cost. And C++ has similar classes. So all of this should be lowercase, unordered map and map. So unordered map is essentially implemented using hashing, and map is implemented using binary search tree. So we'll show how they are used in the sample code. Yeah, so I mentioned this one usage for map is for histograms. If we want to count how many times a value occur, then we can use map. We can use, for histogram purpose, we can use either hash map or tree map because we don't really care about the order. When we care about the order, we use the tree map.